and join us for our lesson in mathematics.
Hello and welcome to Quarter 2, Week 3 of our Precalculus class. By the end of this video, you are expected to illustrate the different circular functions and use reference angles to find exact values of circular functions. Without further ado, let's proceed to our discussion. Let's first have a review of what a unit circle is. If you try to observe the figure, as the red line rotates along the center of the circle, the length of it doesn't change at all. So with it, we can say that a unit circle is a circle with a radius of 1. We know that when the rotation of the radius is 0 degree, the coordinate point that we have is 1, 0. But what if the rotation is 30 degree counterclockwise? Can we determine the new coordinate point? Let's have this figure. Since we are dealing with a right triangle, so we have 30, 90, and 60 degree angles here. Because again, by definition of a triangle, the sum of all the interior angles is equal to 180 degree. The horizontal side is our x, the vertical side is our y, and the longest side is our radius, which is equivalent to 1. So if this is angle theta, our x becomes the adjacent side, our y becomes the opposite side, and the longest side is our hypotenuse. But how do we determine the coordinate of the point P here? The figure that we have here is what we call the 30-60-90 triangle. A 30-60-90 triangle is a special triangle whose angles are 30 degree, 60 degree, and 90 degree. It is special because of the relationship of its side. The length of the shortest leg, which is the side across from the 30 degree angle, is half the length of its hypotenuse. Since our hypotenuse is 1, so therefore the value of our y is equal to 1/2. The longer leg, which is across the 60 degree angle, is equal to the product of the shorter leg and square root of 3. So in this case, our x is equal to the square root of 3 over 2. So therefore, the coordinate of point P here is square root of 3/2 and 1/2. Great! Now, what is our new coordinate point when the angle of rotation becomes 45 degree counterclockwise? So we have 45, 90, and 45 degree angles here because again, if we sum it all, we have 180 degree. So this is our x, our y, and our radius, which is equivalent to 1. If this is theta, this is adjacent side, the opposite side, and also the hypotenuse. So how do we determine the coordinate of point P here? The new figure that we have now is what we call the isosceles right triangle. An isosceles right triangle is another special triangle whose angles are 45, 45, and 90 degree. It is special because of the relationship of its side. The two legs here are congruent. So if our x is equal to a, our y is also equal to a. And again, the longest side is our hypotenuse. The length of the hypotenuse is equal to the sum of the squares of the lengths of the legs of the right triangle. From that, we can say that x squared plus y squared equals r squared. So if we let our x be equal to a and y be equal to a, because again they are congruent, we get 2a squared equals 1 squared, because again our radius is 1. We divide both sides of the equation by 2, we get a squared equals 1/2. Extract the square root, That is just equivalent to 1 over the square root of 2. With rationalization, we get square root of 2 over 2 for our a. So therefore, the value of our x and y here is equal to square root of 2 over 2. You get it now? Very good. Now, how about if the angle of rotation is 60° counterclockwise? Do we have any changes in the coordinate point of our P? Let's try and find out. So this is 60, 90, and 30°. So again, this is just 30, 60, 90 triangle. But in this case, our x becomes the shortest leg. Our y becomes the longer leg. So in this case, all we have to do is simply interchange the value of our x and y in our previous discussion. So our x becomes 1/2 and our y becomes the square root of 3 over 2. Easy, right? At 90°, we have 0, 1. Now, how about when the angle of rotation is 120° counterclockwise? If you try to analyze the figure, these two angles here are equal. So it means that they should also have the same coordinate point. Correct? Yes, it is. They only differ in the number sign. So this one, instead of positive x, this becomes negative. So the coordinate point for this is negative 1/2 and square root of 3 over 2. Now, try to guess the coordinate point when the angle of rotation is 135° counterclockwise. Very good. That is negative square root of 2 over 2 and square root of 2 over 2. Next. Great. The negative square root of 3 over 2 and 1/2. How about this? Correct. It's negative 1, 0. Next. Impressive. That is the negative square root of 3 over 2 and negative 1/2. Next. Amazing. Negative square root of 2 over 2 and negative square root of 2 over 2. Next. Splendid. Negative 1/2 and negative square root of 3 over 2. Next. This is very obvious. It's 0, negative 1. How about the next one? Awesome. 1/2 and negative square root of 3 over 2. Next. Square root of 2 over 2 and negative square root of 2 over 2. We're almost done. Next. Perfect. We have negative square root of 3 over 2 and negative 1/2. And at full rotation, we go back to 1, 0. Do you see the pattern now? Great! Let's take a review on SOHCAHTOA JOSHA COW, where sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent, the reciprocal of sine, which is cosecant, equals hypotenuse over opposite, the reciprocal of cosine, which is secant, equals hypotenuse over adjacent, and the reciprocal of tangent, which is cotangent, equals adjacent over opposite. Suppose we take this right triangle from a unit circle. The horizontal part is our x, the vertical part is our y, and the longest part is our radius, which is 1. If this one is our angle theta, our x becomes the adjacent side, y becomes the opposite side, and the radius becomes the hypotenuse. Since sine is equal to opposite over hypotenuse, we have sine theta equals y over 1, or sine theta is just equal to y. For cos equals adjacent over hypotenuse, so we have cos theta equals x over 1. So our cos theta is just equal to x. For tangent, since we have opposite over adjacent, so tangent theta is just equal to y over x. For cosecant, since it is just the reciprocal of sine theta, so we have cosecant theta equals 1 over y. For secant, reciprocal of cosine, so we have sec theta equals 1 over x. For cotangent, the reciprocal of tangent, so cotangent theta equals x over y. We now have the different circular function of a unit circle. Now, to further understand it, let's have an example. Determine the 6 trigonometric values of the following. 1. When theta is equal to 45 degrees, and 2. When theta is equal to 5 pi over 6. First, locate and determine the coordinate point when our angle of rotation is 45 degrees. Based on our previous discussion, the coordinate point when the angle of rotation is 45 degrees is square root of 2 over 2 and square root of 2 over 2. So, sine 45 degrees is just equal to square root of 2 over 2 divided by 1, which would give us square root of 2 over 2. Cosine 45 degrees is equal to square root of 2 over 2 over 1, which also would give us square root of 2 over 2. For tangent 45 degrees, that is just equal to square root of 2 over 2 divided by square root of 2 over 2, which would give us 1. For cosecant, since it is reciprocal of sine, so cosecant 45 degrees is just equal to square root of 2 using rationalization. Similar to secant 45 degrees, that is just equal to square root of 2 using rationalization. And also same with the cotangent 45 degrees, since it is just also the reciprocal of our tangent, so which is 1. Let's have example number 2, which is theta equals 5 pi over 6. Since the given is in radian, so we need to convert a radian into degree. How to do that? Simply multiply the given by 180 degrees over pi. Simplifying that one, that would give us 900 degrees over 6, which is just equal to 150 degrees. Locate and determine the coordinate point when the angle of rotation is 150 degrees. That is just equal to the negative square root of 3 over 2 and 1/2. That is based on our previous discussion. And using that coordinate point, we can now determine the 6 trigonometric values of the given, which is 150 degree. So, sine 150 degree is just equal to 1/2 divided by 1, which would give us 1/2. Cosine 150 degree is just equal to the negative square root of 3 over 2 divided by 1, which would give us negative square root of 3 over 2. For tangent 150 degree, that is equal to 1/2 divided by the negative square root of 3 over 2, and with rationalization, that is just equal to the negative square root of 3 over 3. For cosecant 150 degree, since that is reciprocal of sine 150, so that is just equal to 2. For secant 150 degree, the reciprocal of cosine 150, and with rationalization, that would give us the negative 2 square root of 3 over 3. For cotangent 150 degree, the reciprocal of tangent 150 degree, and with rationalization, that is just equal to the negative square root of 3. That's how we determine the 6 trigonometric values of a unit circle. Now let's have another example. Use reference angle and appropriate sign to find the exact value. Number 1, sine 210 degree. Similar to our previous example, the first thing that we need to do is to locate and determine the coordinate point of the given degree. So in this case, that is 210 degree. So based on our previous discussion, the coordinate of 210 degree is equal to the negative square root of 3 over 2 and negative 1/2. Our x-coordinate here is equal to the negative square root of 3 over 2, which means that this is the length of our adjacent side. Our y, which is equal to negative 1/2, which means the length of our opposite side, and the hypotenuse equals 1 since we are dealing with a unit circle. So using sine equals opposite over hypotenuse, so sine 210 degree is just equal to negative 1/2 divided by 1, which would give us negative 1/2. Therefore, sine 210 degree is equal to negative 1/2. That's all for our examples. Now let's try this exercise. Determine the 6 trigonometric values of the given. Theta is equal to 120 degree. Again, the first step is to locate and determine the coordinate point of the given angle. You are given 5 seconds to answer what is asked. Are you ready? So, what is sine 120 degree? Good. That is square root of 3 over 2. How about cos 120 degree? Great. That is negative 1/2. How about tan 120 degree? Amazing! That is negative square root of 3. Next, cosecant 120 degree. Splendid! That is 2 square root of 3 over 3. Next, secant 120 degree. Magnificent! That is negative 2. And how about the last one? Cotangent 120 degree. Perfect! That is negative square root of 3 over 3. So to wrap it up, You don't need to memorize the whole lesson. Simply familiarize yourself with the coordinate points of 0, 30, 45, 60, and 90-degree angle. And also don't forget the SOHCAHTOA CHOSH CHAO. See you next lesson. Goodbye!